Any questions, please?
I have one question.
Yes.
So the topic was very excellent topic you have lectured on.
Thank you.
The problem, instead of the chessboard, if we take up a problem of folding a sheet, take a
Yes.
sheet
Yes.
and fold it.
Yes.
So how many times you fold it, you measure the height.
Yes.
Are they not equivalent?
They are almost equivalent because
This growth also is an exponential growth.
yes, and the number, if you fold the sheet
Fold of
n
40
time,
times,
you'll get 2 to the n time
you can
the
reach the moon.
you can reach the moon in
can reach
about
the moon.
50 foldings. Well, I think
If
or
I remember correct,
42.
42.
42. That's possible.
42 fold
Mhm.
you make,
Mhm.
you will reach the moon.
Yes, there are many possible variants.
In practice, you cannot do it more than 7 times.
7 times.
So it was believed.
So hard.
What he says is interesting.
That is
It,
what is the mathematics comes.
it was asserted that no one could fold more than 7 times a same piece of sheet. And 10 years ago, a scholar, an American scholar named Brittany Gallivan, was a girl, succeeded in fold a sheet of paper 12 times. 12 times. And her idea, I didn't read exactly her text, but her idea was to fold in a particularly clever way. The problem in folding is not that the sheet is becoming too small, because you can, even if you take a big piece of piece of paper, the same kind of problem arise around the seventh folding. But the problem is that at the place of the folding, le pli, you understand what I mean? When I fold it, the place here,
You get the
there is a physical tensions, and that become more and more important, and independently of the size of the sheet. So it needed a clever girl to imagine another kind of way to fold a sheet of paper, and now it's about 12.
That if you take a toilet paper,
She took toilet paper to do it. Sorry?
for that it is 12 fold.
12 fold, yes. And I think we can find videos on YouTube on this story. But she published a paper, a real scientific paper, and she was
Exponential growth.
she was 20 years old. I think it was not
And this
not
folding
very aged.
problem, I feel in some sense they are isomorphic. In some sense.
Yes,
Isomorphic.
their mathematical structure are identical. Yes.
Yeah, they are the identical.
The only difference is that in the chessboard problem, you sum up all the on here you don't sum up the sizes of the different folding. You just consider all one. So you at the end you are at 2 to the n. Here we are at the sum from 2 to the 0 to 2 to the n. So, but essentially it is also an problem that show exponential behavior. Yes. Yes.
Previously explained that Euler used to sum up the sequences, you said no. Euler,
Yes.
Leonard Euler.
Yes.
Any specific sequence, can you tell?
He used linear recurring sequences.
Linear.
These are sorry. These are linear sequences in which, well, for Fibonacci, each to compute some term, you take the 2 previous one and you sum them up. Okay, but instead of consider the 2 last terms, you may consider, well, the last one and the one 5 places before. Okay, that would be another linear recurring sequence. Or you can even take, well, twice the previous one, then the opposite of the 3rd previous one, and you get another linear recurrent sequence. Okay, and these are fascinating objects, very interesting objects. Okay, the one used by Euler was of rank 22, I'd say. That means it involved to compute each term. You needed to well, you make calculation involving all previous term until the one which is 22 places before it, about it, because they counted for the age at which you have children, etc.
Your talk was interesting.
Sorry.
Your talk was interesting, man. That you made all the what are the mathematical terms? No, you applied to that particular problem. Suppose you said no, counting the walls in German, they applied. Then population. Therefore, you have given the insight to apply the mathematical ideas in that real-time problems.
Mhm.
Thank you.
Thank you. Thank you.
Please appreciate.
She's appreciating you.
Yeah. Thank you. Thank you so much. So maybe now it's your turn.
Thank you. So on behalf of Pi Mathematics Association, I thank you, Professor, for giving this wonderful lecture. I hope many students for many old people might be knowing what you said, most probably, but young students could have been encouraged and motivated by what you spoke. And it is a kind of opportunity that we all had today. And I should mention one thing, that people from Kanchipuram, madam and other students, they had come here all the way. They were here at 4 p.m. So a special thanks to them for being here. Okay, so let's move to the next part of the program.
Professor Sanmugam to felicitate Benoit Rittaud.
Sir, photo. So, Professor, he is Professor Shanmugam, retired from Anna University, who spread mathematics like us. So, yes.
I was in France first.
Where
I was in the north. What is it? Some G University, the Compi.
There.
Compi. Yes.
There.
I was there.
இருக்கட்டும் சொல்லலாம்ல எது என்ன இந்த நம்பர் சொல்ல வேண்டாமா இப்படி பிரிக்க வேண்டாம் அப்படி இந்த கவர்ல எடுத்து அப்படியே சொல்லலாம் பிரிக்க அவர்கிட்ட எடுக்க சொல்லுங்க. Sir, we had presented this memento on the remembrance of the birthday occasion of Paul Erdős, one of the great mathematicians. Incidentally, next Monday was his birthday. So I hope it is 105th birthday of Paul Erdős, next Monday, 26th of March. So remembering such a great mathematician, we had just prepared this and given to you. So I think that will be apt occasion. You speak between two important days. One is Paul Erdős, which is upcoming now, and Pi Day, which is already gone. So it's just between these two important days.
And his birthday falls on our National Science Day.
Oh, yes.
28th February
How do you know that?
1974. Your birthday?
It's available in net, sir.
So, which day is it for you?
Science Day, National Science
It is a
National Science.
Proud of that.
So I request Professor, sir, just please give, sir, memento. Venkatakrishnan, yes, sir? Professor Venkatakrishnan. Madam. Yes. Please, sir. என்ன இருக்குல்ல அது ஸ்டாண்டா So I request our association member and student of Professor Srinivas, Nagaprasadu, to honor with a memento for Professor Srinivas.